We're back with Core 2. We mixed and matched a bit of arithmetic and geometric. What's the matter?
Oh, I'm really thirsty, Wayne.
Oh, actually, I'm really thirsty too, now that I think about it.
Yeah.
I've had a cup of tea, actually.
Yeah, tea would be good, but what type is he? We've got quite a few.
I'm trying to think of what's in the cupboard now. I'm just trying to picture it. I've got velocity,
insanity,
monstrosity,
capacity,
Mr. T,
faculty,
cavity,
RESPCT,
and PG tips.
Well, we should sort that out when we finish the video.
Anyway, we mix and match.
Mix and match.
We mix and match. And some of the stuff that was arithmetic was in that video, and then we're in geometric now. So we've mixed and matched with
they're
the
quite
book.
similar, really. But geometric does have some differences.
Yes. For example, instead of having a common difference, it's
has
got
a common ratio. Which is what you multiply each number you get by to get a new number.
So it doesn't go up in a constant amount
No,
like it does in
does
arithmetic. That's the main difference.
And there's different notations as well. Like in geometry, we have R, which you don't have in that one.
R, which stands for the ratio. We've got a nice formula here for the nth term.
Yeah, which is one we also you do similar things. Something you do in geometry, you don't in arithmetic, is finding the limit.
Yes, yes, finding the limit, because they converge to limits. You see, in some geometrics,
but only when it's below 1 and above 0.
Yes, but we'll get onto that in a minute.
We will get onto that.
This is the nth term for geometric.
Yeah.
Because it has a ratio instead of a difference, we can't use what we used at arithmetic.
It is different, yeah.
So it's A is
still our first term.
I'm going to write A1 for your first term.
Yeah.
R, I'm going to put CR. It stands for
common ratio.
N is the nth term.
It is -1 like we did before, but as an indice.
So if I get an example up from the book,
yeah.
I'll read it out, you write it down. This is the sequence, the geometric sequence.
Okay.
7,
Alright.
21, 63, bingo, and 189. And the question asks, what is the 10th term?
Well, we need to work out a few things for what's the 10th term. First, we need to find out what R is. It's not quite as simple as it is in arithmetic sequence, but there is a trick.
There is a trick indeed. What you do is you take the second number of the series.
Yeah, and you divide it by the first number of the series.
In this case, it comes out as a nice number.
It does.
Just
Which is 3.
But some of them can be points and decimals and stuff. It's not.
They can be quite horrendous, but this one's alright.
This one is alright.
So now I've got that bit.
We know A.
We do know A.
We know N. It's 10.
Yep.
And minus 1.
So let's do it. Arithmetic sequences do get big numbers. I think we will use a calculator.
So I'm going to have 7 times 3 to the n, which is 10 minus 1, so 3 to the 9 equals. So first do 3 to the 9 by your BIDMAS laws. 3 to the 9 times it by 7.
3 to the 9 times 7 is a big number, Wayne.
It's a big number, are we ready?
It is 13,000.
Yep.
Oh, it's bigger than that. 137,000.
137,000.
781.
781.
It's huge.
And these are the sort of numbers you have to deal with.
Yeah.
But again, nifty formula comes up all the time, given to you in the exam booklet, so you don't have to remember it.
Yeah, remember it, which is very nice.
Nth term, that's what this one is.
Yeah, it's nth term.
I'm just going to put UN, which stands for nth term.
It does. And like the other one, it has finding the sum of finite
yes.
things.
Forgot to mention that.
It is the same as finite and infinite. They do have sequences that go on forever, which is when the limit to a conversion to a limit comes up.
Yes, it will always converge to a limit if it's an infinite thing.
And it could end.
It could end, yeah. You could just say there's only 25 terms in this sequence. Let's get on to a few examples of using this before we go on to the converging to a limit.
Oh, alright.
Let's do that.
Yeah, let's crack on.
Fancy some tea though.
Yeah.
We're back.
We are back. Hello.
We said we'd come back with a bit more difficult question. So what we've done is we found a question that uses this nth term formula we just learned.
Please use it.
A r to the n minus 1.
But looks at it a different way.
Bit of a twist.
Bit of a twist.
So I'll give you the question, you can write it on the board.
Alright, ready? Okay.
You ready? It says the nth term of a geometric sequence is 2.
Okay. Oh. Yes.
2 times 5 to the power of n minus 1.
Alright.
And the question says first, to find the first 4 terms, so U1, U2, U3 and U4, and then it says to find the common ratio. So what we've got to do is, n is essentially the term, so we've got U1 is the first term, 2 times 5 to the power of 1 minus 1 is to the power of 0,
from our indices, we should know that for anything to the power of 0 is 1. So 2 times 1, that's 2. Yeah.
Then you put 2 in, because it's the second term.
And you keep it up like this.
2 minus 1 is 1.
1.
5 to the 1 is 5. 2
Yeah.
times 5, 10.
10, and we do this again. So then put the 3 in.
3 minus 1, 2. 5 squared is 25, times 2 is 50.
It's a bit sloggy this really, but it's okay.
And 5 to the 3, because it's 4 minus 1, so 5 cubed is 125, times 2 is
It's 250. There isn't really a fast way to do this, sadly. It is a bit like this.
And that was part A, was to work
That was
out
part
the
A.
first 4 terms.
What was part B?
B is to work out the common ratio.
We should remember from last time. Common ratio is the second term over the first term.
Yep, so 10 over 2 is 5.
You should be able to notice that from looking at them anyway.
Yep, well you've got A times R to the n minus 1, so you should be able to see it right from there, that what R is.
Yeah.
But as a general rule, second over the first is your R.
It is. So is that question?
That is that question.
Oh, that's done really. That's quite
nifty.
it's quite nice.
But what about if we have sums of geometric series?
That's something quite exciting.
We're back, and
Yeah,
we're with the sum is what we said we're going to now.
Yeah.
Just like with the arithmetic ones in the previous video, it's just the first term plus the second term plus the third term onwards.
Yeah. For a set amount or a finite sequence, you find out what they all are added together.
As you can imagine, because it's multiplied each time by a number, you get some very, very big answers.
Big.
And because it's a common ratio, not the common difference, there's actually a whole new formula. to learn.
Hooray! Okay, and that formula is, drum roll please.
Well, if we have S, this means the sum of, so
Alright.
S equals A, bracket, R to the power of n minus 1, over R minus 1.
Is it all over?
Like that.
Alright.
And that's your new formula for the sum of. Now, just like in arithmetic, we use this Greek letter sigma.
Ooh.
Ooh. We have sort of n at the top, and at the bottom it normally starts at 1, just to go up to n.
Yeah. And like before, that's the number you start at, or the term you start at.
So you need the nth term, like that.
And we have a question.
we have an example.
So let's go and do that. I'll grab red pen.
Are you ready?
I am ready.
It says, find the sum of the first 10 terms in the geometric series. 2 plus 6 plus 18 dot 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 dot
Oh.
dot. Right. So how do we do this, Triff?
Well, first you need to find out what R is.
Yes. So we do the second over the first to find out what R is. I'll put it here. R. 6 over 2 is just 3.
It is it's just 3.
What is A? First term of our sequence.
2.
And we need N. What's N, Triv?
N is 10.
N is 10, the number of terms.
Okay.
So now we quite simply use this big formula. So the sum of this, sigma, I'm using sigma instead of S now because we're using it properly, is A, which is 2
2.
times bracket 3 to the power of 10 minus 1
It's quite a big number.
over 3 minus 1.
Okay.
Calculator, please.
Alright.
Do you know how much it's cost me?
I recall you saying it before at some point. It was,
Pretty sure I've said it once or twice.
yeah, once or twice, and it
It wasn't cheap.
wasn't that cheap. And I think it cost more than a baby goat.
Yeah. But less than an iPad Air.
Yeah. That's quite a big range, that is.
Yeah, let's narrow it down a bit. Less than a Hoover. Less than a Dyson Hoover.
Less than a Dyson Hoover.
More than a toy Hoover.
More than a toy Hoover. I think it was... what was it less than? I think it was less than... What was less than a Hoover?
Oh, I don't know. It's 50 quid.
It was...
Oh.
I think that is... It is in that range.
3 to the 10
Is
minus
quite a
1.
lot.
That is a big number.
Am I going to write that down?
2 times n, so now I'm just going to do it all in one big
All in
massive
one big
thing.
thing? Alright.
Divided by 2. You ready for this massive, massive number?
Oh, no. Bit lunges, stretching. Okay, I'm ready.
Go with the flow.
Alright.
59,000
59,000.
and 48,048.
Oh, I forgot how to do 1,000.
Which is a big number.
There's a big number.
That's how you do it, that's the sum. This is your new formula. You need to get practicing with this.
And they do mix together sometimes, so you can find out what n is.
Yep, like before the arithmetic, if you watched our previous video, you might have to work out n, yeah? From the previous.
And then they added in another thing that you ask you something else.
About converging to a limit. New thing. Converging to a limit. You alright? So, some geometric things, because they have a common ratio. If the ratio r is less than 1, but greater than -1, then the thing will converge to a limit. Because if you think about it, you've got r to the power of n, but n is the number of times.
Yeah.
Well, if r is like 2/3, because it's a fraction, or -2/3, because it's a fraction,
As it gets bigger,
as n approaches infinity,
I will get really little.
and r, this value,
Converge to
a
0.
fraction to near infinity, it's said to converge.
That means it gets closer and closer and closer and closer, but never touches. I love biscuits.
It never actually reaches 0, but it's said
But
to converge to a limit.
it gets
Because if
there.
you think of a quarter to infinity,
Yeah.
it will eventually converge to
Times quarter by
0.
quarter, eighth. Times by eighth,
It
16.
gets progressively
And it keeps
smaller.
going.
Yeah.
What number will get to infinity as well? Ooh.
Yeah.
Yeah.
That's converging to a limit. Now, for geometric progressions that converge to a limit, we have a special formula,
You do.
which is a over 1 minus r, and that will give you your sum to infinity.
You actually draw a graph of this.
Yes,
And if our limit is like 7, a line that it will never touch, but it will get really, 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 really close,
Yes.
and it will just sort of stay close forever.
So now let's actually do a question about a geometric progression that will converge to a limit.
Okay. Alright.
Are you ready?
Well, can you pass me that pen? Right.
Find the sum to infinity of the geometric series
Okay.
1 plus
Ooh. Okay.
2/3
Ooh.
plus 4/9 plus 8 over 27 plus dot 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 dot.
Okay.
Alright.
So first, we need R.
Yep. I'll do it in blue.
Oh, okay.
The common ratio, you do the second term over the first, so it is just 2/3, but I'll write it. R equals 2/3. We need A, which is 1.
There's one.
So you've got 1 over 1/3. Because you've got 1
Yeah,
minus
minus
2/3.
Now that's
3.
3. Yeah.
So it will converge to a limit of 3. So it will get progressively close to 3.
We get really, really close.
But never
Never
actually
touch.
it. Like if this value was 3,
Yeah.
it would get really, really close, and then just
Change
bigger,
it.
bigger, 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 bigger. But it will never approach. It will like, never actually touch 3, but it will get so close. It might
Very,
as
very
well have.
close. And they might actually ask you an exam what it means to converge to a limit. What does that?
Imply. Yeah, and it says as n approaches infinity,
What happens to?
the sum will
Yeah.
converge to a number. Because you'll be plussing on such a small number as this goes on. Like, you can see it's getting smaller. 1, 2/3, 4/9, 8 over 27.
And
Eventually it'll be
quite
so
big.
small that you might as well not plus it on.
Yeah.
it will
it'd be
nearly get
more
to
or
3.
less 0. So what is it? Quite close.
And that should be something new. So remember this formula, although it will be given to you in the exam. Remember this. This is an important fact. R has
Yeah.
to be between these.
There's something you can quote in an answer.
Yes.
It may well be a mark point.
And you can see R here is 2/3. If it was bigger than 1, then it would just keep multiplying and getting bigger.
Yeah. I think that's pretty much it for
That is pretty
geometric
much
series.
it. I think we should go on to some test yourself stuff. Then.
Oh, that's an excellent idea.
I love biscuits.
Harry loves biscuits. Okay, now on to the test yourself question.
Test yourself, page 59, question 6 of this book.
This book's still quite shiny.
Bloody hard question, this one is.
This is quite evil, actually.
Yes.
Took us a very short while to figure it out.
We got it, We'll do it.
Alright, so let's do it.
Right, I'll
I'll read
mine.
it out.
Yeah.
Okay, so it's question 6. We've already said that. A geometric series has first term A and common ratio R, and A is greater than 0, as is R.
Right.
Okay, part A states the second term of the series is 4.
U2
U2
is
equals
4.
4. And the eighth term is a
Right.
half.
Is R.
The question is, show that R equals 1 over root 2 and find the value of A in surd form. That's a hint then.
Okay. Just going to talk you through what I do while I'm doing it.
I
I
am.
do some bit of colours.
Right, so we know an equation before, which is AR and N minus 1. So we know for this one, which is the second thing in our series, N is 2, N minus 1 is 1, so it's AR to the 1, which is the same as just AR, and that equals 4. Same thing here, AR to the 8 minus 1, AR to the 7 equals a half. So now we want to find R on its own, so get rid of both the A's. We're dividing the bottom one by the top one, which means it's a half over 4, which ends up being just an eighth. R to the 6th equals an eighth. So now we need to write an eighth in factor of 2, so it becomes 2 to the minus 3. Well, rules, it's 1 over 2 cubed, and to get it 1 over becomes a minus. Then to get the 6th over, it's the same as putting a root, so you put 1 over 6th outside the bracket. Then it's quite simply 2 to the minus half, which is the same as that, which is
what we want.
what we want, which is quite friendly.
Let's work out A.
Now to work out A.
I'm going to do it in that one there, just to let you know, Triv.
Oh, alright.
And I'm going to do it in green, because
Cool.
I like green.
I like green too. So, we're just adding another thing into the equation that we know. Now we know what R is. We can add it in, we know it needs to equal 4. And 4 is the same as 2 squared. So now we just divide through. A equals 2 squared divided by 2 to the minus a half. No. Yes, no, yes.
Equals 2 to the 5 over 2, because I add them.
Yeah, you add them after flipping the fraction. Yes.
So that's divided this side, and by your laws of indices, division, x to the a divided by x to the b is x
So
to
it's
the a
A
minus
minus
b.
B.
So we've
Yeah.
got 2 minus minus a half, 2 plus a half, 5 over 2.
And that gives us our A value.
Yes.
Okay. So do you want to read the second part, Wayne? And
You want the 3 coloured pens?
I would love the 3 colour pens. I'm going to stay this side for extra room.
Okay, so we have 6b. Find the sum to infinity of the series in the form... Oh, just write sum to infinity.
Yeah.
In the form k, open bracket, root 2 plus 1.
Okay. So you got something we need for. All right.
So we have another formula for the sum to infinity, and it's a over 1 minus r.
That's what we've got.
Where a, we just worked out down here, is
We did.
2 to the power of 5 over 2. And that's all over 1 minus r, which is 1 over... Oh, we'll write it in the other form, actually.
Yeah. Okay.
2 to the minus a half. We'll write it in that form, because that's in number form.
Yeah. Keep it consistent. Hopefully it means less mistakes.
Yes.
Okay,
Now-
okay.
Because this is a root, this is 1 over root 2,
Yeah.
because it's a root, we want to get rid of the root, which is from core 1, you're
It is.
rationalising the denominator.
So let's do that.
So to do this, if you remember, we've got to times by the conjugate pair.
Yeah.
So we've got to times the top and the bottom by 1 plus 2 to the minus a half.
All right. So let's do that. So 1 plus 2 is minus a half.
And on the bottom, 1 plus 2 to the minus a half. Except, we're going to slightly change this, because we want it in powers of 2, and 1 is 2 to the power of 0. That's quite hard to notice,
It is.
but it's 2 to the power of 0.
Ooh.
So now that they're all in powers of 2, it just makes it a bit easier to plus and minus when you're
The
trying.
indices, yeah.
Now, from core 1 you should know when you're timing by conjugate pairs, you only have to do that times that, and then that times that.
This is also
That's
the same.
also 2 to the naught. So you have to do the first 2 and then the second 2.
So
2 to the naught is 1. Are you starting with the denominator or the numerator?
I'll start the denominator.
Okay, yeah. 2 to the naught is 1 times 2 to the naught is 1, which is just 1.
Yeah.
And then minus 2 to the minus a half times plus 2 to the minus a half is just going to be minus, and then 2, because of our laws of indices, it's going to be, let me think about this a little second. Thinking faces on, it's very late at night right now.
A minus a half plus minus a half.
Yep, it'll all come down to just minus a half, 1 over 2.
Yeah?
Yeah?
Yeah.
No, as in minus a half, minus 1 over 2.
Oh, yes, sorry. Yes.
It's very late.
It is
It's
quite
very
late.
late right now. At the top,
Sounds a bit
2
nice.
to the power of 5 over 2 times 2 to the power of 0. By our rules of indices, you plus the 5 and the 2 and the 0. So you just get 2 to the 5 over 2. And then 2 to the 5 over 2 times 2 to the minus a half, you've got 5 over 2 plus minus 5 over 2. So which is 2 to the power of 4 over 2, and 4 over 2 is just 2, so it's just 2 squared.
It is. Right, now you can actually do something.
Yes, but the next step is just to get this as one whole number. You just do 1 minus a half, which is
That's just a half.
just a half, but write that in form of 2. So we'll do the top first. You've got 2 to the power of 5 over 2 plus 2 squared all over half, which is 2 to the minus 1.
Okay.
Now, again, by your laws of indices, that divided by that is going to be the power of that minus the power of that, except that's negative, so it's minus minus.
Means it's positive.
It means it's positive, but it's 5 over 2 plus essentially 2 over 2, so 7 over 2, plus, and then 2 divided by the minus 1 is plus, so it's cubed.
It becomes 2 cubed.
And that's that like that, but that's not quite the full question.
Because it wants it in the
It wants
form.
it in that form.
This.
Now,
Okay, I'm going to switch to blue now.
you can switch to blue. The only thing we don't actually know about this is the K. We know what this is and what this is.
Yeah.
We know how to work out what K is.
So I think we should expand these brackets first.
Yeah.
So I'm going to write this all again down here. 7, 2, well, except I'm going to expand the brackets. It means K root 2 plus K. I think we should write these a little simpler.
Yeah.
So
Okay.
this is actually
8.
2 cubed, it's actually 8.
Yep.
Now we've got a constant here, we've got K times root 2 plus K equals this. So if we make the assumption that that means K equals 8, we can test it by
Yeah.
seeing if these two things are equal as 1. So we form another equation. 2 equals 7 over 2 equals K root 2, which is the same as
2 to the minus 1. No?
2 to the
2 to
half.
the half, sorry.
Then, for all indices, we divide both sides by this, which is the same as taking away there,
Yep, so you get 2
2
to the 6 over
over
2.
2, which is the same as 2 over 3,
Yep, and 2 to the 3 is 8.
8. So that means both of them equal 8. That means K equals 8.
So for the final step, just to actually write it in this form, you're going to have 8,
8
open bracket, root 2
plus 1.
Now this is a really, really hard question because firstly you've got to notice that you're going to have to rationalise the denominator, which takes a lot of knowing your indices rules to be
It
able to
does.
do. Then simplifying it all down, there's a lot of places you can make a mistake. Then it wants it in an awkward form, and you've
It
got to
does.
then convert stuff. Then you've got to prove that that stuff works before finally answering it.
Yeah. And this is about as hard as the exam questions get, but this is an exam question, so
This
it
is-
can get this hard.
This was in AQA
2002?
2002. Or
Yeah.
2001? Page 59. Pretty sure it was 2002. It was 2001.
2001.
AQA 2001.
The spec has
Genuine paper.
changed since then, but it hasn't got any easier.
No, it could be as hard as
It could
this.
be as hard as this.
This is combining a lot of skills and it's particularly tricky.
Yeah, I think in fact it's combining nearly every single skill in the chapter.
Yes. Which is really useful for us as a revision video.
And hopefully for you as well.
Yeah, this can hopefully show you how much you need to know about everything, because
Yeah.
although they might ask a question that looks like it's on this, it will use other stuff. That's what the exam board's pretty good at.
Yeah, I like dressing stuff up.
Yes. So let's sum up this video. Sum up geometrics.
Alright, let's get on to that. Let's crack on.
Core 2, Chapter 4, is it? Yeah, Chapter 4.
Chapter 4. And that sums up all of our sequences in Core 2 actually.
Yes, we did mention in the previous video, not so much in this one. We've mixed and matched a bit in terms of
We have.
the last two chapters, both of the geometric and other sequences, basically.
Yeah, we
They mix
split
it
them
up
up much more
better.
definitely.
Yeah. Like the book just splits it up into random skills and then builds on them.
Yeah.
We've split it into arithmetic and then geometric.
Yeah, it's more explaining how to do them as opposed to teaching you, because you can do the revision bit. This is revision, you've been taught that bit.
Yeah.
Yeah. So we started off with what a geometric progression is, or
Yeah.
sequence.
The idea that instead of a common difference, it's a common ratio, so
Yeah,
it doesn't go up
changes.
by an even amount.
That means it's got different equations as well for the nth
Yeah,
term.
it brings
It's
in
got,
R. So it's, I'll get a pen, where's a pen? Here's a pen. A times R to the n minus 1. That's the nth term.
Yeah. Then we have the sum of a series,
Yeah.
which is
A
a
1
minus R.
That's the sum to infinity. Yeah, and that's for ones that converge to a limit, because that's something.
Yeah, and that only
If-
happens when R is more than minus 1 and less than 1. If that's when it's a fraction, that's when the things happen.
Yeah.
And
There was one more formula, I can't remember off the top of my head.
but it was a sum of series of a set of a finite number of things.
Yeah, so it doesn't converge to a limit, you're just adding them all together and you get huge numbers, so you will
Very
need your
large
calculator.
numbers.
It's something like A bracket R to the n minus 1 over R minus 1. I'm pretty sure that's it.
I think that's it, yeah.
Yeah.
And that's the sum.
But that's given to you in your exam booklet.
that is.
You don't
Yeah,
have to
right.
remember any of these, in fact.
No.
You just have to remember how to use them. And
The
when
thing
it's
you need to remember with this one is what it means to converge to a limit. You may have to draw. It may ask you what the asymptote of the sequence is or
It
something.
might, like we did it earlier. Here's a small version, but
Yeah.
like that. And then
And this has the asymptote where it stops at 3 when we did it earlier.
Yeah.
Then you've got to understand what that means to when, as something tends to infinity, what does the other number tend to? We worked out how to do that as well.
Yeah. And then the test yourself is one of the most difficult questions I've ever come across.
Yeah, incorporating
in
more
maths
things.
so far.
Than I've ever seen.
Yeah, that's
And
incredibly hard.
That's a hard question. If you can do that question, you should be reasonably confident.
If you can reason with yourself of what we were doing and why we were doing it,
Yeah.
and how it works, you're pretty good to go. You're pretty good.
Yeah,
Pretty much sums up geometric.
I think it does, yeah.
So the other video before this was arithmetic, so if you need to revise on that, go click on it.
Yeah. As always, I think we mentioned it in the last video, but if there's anything that you didn't think we made clear or a question that you can't do to do with this, just mention it in the comments below, give a link or something, and we'll try and answer it in another video.
Like if this question didn't make any sense, we've got this book. We've also got the Edexcel books. If you just give us the page number and the actual number of the question,
Then
we'll try
do
and run
another
through it
video.
for you.
Yeah.
But it's like 10:30 at night right now. We've been doing maths for ridiculous time.
Too long.
Too long.
Too much maths has happened.
Too much maths.
I think now it's time to
Go to bed.
go to bed. So he's been Wayne Lack.
And he's been James Trebet.
Let's crack on.
We're gonna get some tea.
Good plan. What sort of tea?
I don't know. What sort of tea do we have? I think I have Velocity.
Right.